Another data structure down, hash tables. By now, you should absolutely love them because, well, they're very useful. They're used everywhere. And the funny thing is that it's probably the most common interview question where you use a hash table to optimize something, kind of like we saw in our interview question. By using hash tables, we optimize those nested loops that are O(n) squared to O of n, linear time. This is a question that comes up again and again that I promise you, if you notice this pattern, it will be extremely useful for you in an interview. And undoubtedly, you'll have an instance where you have to use it and follow this exact same step. In this section, we learned that hash tables have really fast lookups, but remember, we need a good collision resolution needed. Usually, we don't need to worry about this because our language and computer underneath the hood take care of that for us. It allows us to do fast inserts, and depending on the type of hash tables, such as maps in JavaScript, we can have flexible keys instead of an array that has 0, 1, 2, 3, just numbered indexes. The downside with hash tables is that it is unordered. It's hard to really go through everything in order, and also it has slow key iteration. That is, if I want to grab all the keys from a hash table, I'll have to go through the entire memory space as we saw when we built our own hash table. Looking at the Big O cheat sheet, we can see that hash tables has a search, insertion, deletion of O of 1, but in worst case, due to collision, there are some O of n operations that could happen. And if we go to our mind map, we can now cross off hash tables off our list. We understand the Big O complexity. We also understand that with collisions, we might want to use something like linked lists, which we'll talk about very shortly. In our exercise, we just simply used arrays. We also learned the idea that hash tables in interviews are usually useful for improving time complexity, especially of nested loops. The trade-off being that we can have fast access, but more memory. Going back to our question that we had a few lessons ago, where we had to find the common item of two arrays. We had array 1 and array 2, and we had to see if any of these arrays contained similar items. We had one that didn't, and the second version, where x and x, both arrays contained x, it would return true. Our first iteration of that exercise, we had to use 2 for loops that were nested. So that created A times B complexity. However, using hash maps, we were able to just do 1 for loop and optimize this function. Like I said before, this is such a common pattern that we'll be talking about it later on in the course as well when we talk about dynamic programming. If we go back to our cheat sheet that I shared with you at the beginning of this course, we can now cross off a few things off the list that we haven't talked about in the good code checklist. We talked about the good use of data structures, when to use hash tables over perhaps arrays. The idea of code reuse and not repeating yourself is something we've been following and should be familiar to all of us. We also talked about modular code and making code more readable, which allows code to be more maintainable and testable. We talked about how usually in an interview, we want to avoid the O(n) squared operations, and we saw that we're able to do that with hash tables. But we did see that with a hash table, we had to increase our space complexity to O of n because we created this new variable that keeps track of all the items in the array. So that is the trade-off. And then we can cross off a few heuristics. For those who don't know, heuristics are kind of like rules or simple tricks that are going to come up over and over and over that you can use in an interview. Hash maps or hash tables are usually the answer to improve time complexity. Again, hash tables are some of the best way to optimize your code. And looking at time versus space trade-off, sometimes storing extra state in memory, like we did with hash tables, can help the time or the runtime. And then finally, space-time trade-offs. Hash tables usually solve this a lot of the time. You use more space, but you can get a time optimization to the process. I know we've only talked about 2 data structures, but I think these 2 are the most important. Moving forward, we're going to use them to learn about others. Good job getting this far. Take a nice little break, have some coffee, and I'll see you in the next video. Bye-bye.